this video, I am going to tell you about the periodic table. Mendeleev's periodic table. Before the discovery of the subatomic particles, scientists struggled to find ways of ordering the growing knowledge of elements and their chemistry. When the elements that were known at that time were sorted by mass into a table, patterns emerged at regular periods along the table, giving rise to the term periodic. The earlier tables were incomplete as some elements were forced into a position to fill gaps which appeared during the sorting process. Other elements were placed in the wrong group as they were sorted strictly on their mass and had their chemical properties ignored. There were many early versions of the tables as scientists in different countries grappled with the ordering of the elements. In 1869, the Russian chemist Dmitry Mendeleev created his first draft of the periodic table. He organized the elements into vertical columns based on their properties and the properties of their compounds. He then started to arrange them horizontally in order of increasing atomic mass, and as he worked, he found that a pattern began to appear in which chemically similar elements fell naturally into the same columns. There were exceptions though, as some elements didn't fit the pattern when arranged by atomic mass. Mendeleev worked to include all the elements, but he didn't force an element to fit the pattern. Rather, he left gaps in the table that he thought would best be filled by elements that had not yet been discovered. He also switched the order of the elements to maintain consistency down the columns. Mendeleev quickly realized that elements with the same properties should be placed in the same column. He realized that gaps in the table must correspond to elements that had not yet been discovered or isolated. He used the properties and trends of other elements in the group with the gap to predict the properties of these undiscovered elements. Mendeleev left a gap between silicon and tin and used his knowledge of the properties of those two elements to make predictions about the physical and chemical properties of the undiscovered element. He called this element ecosilicon, which comes from the Greek like silicon, and when the element germanium was discovered in 1887, it was found to almost exactly match the properties Mendeleev had predicted. No one doubted that Mendeleev had got the right idea about ordering the elements. Strangely enough, Mendeleev always denied the existence of an eighth group of elements, even after the discovery of the noble gases in Mendeleev's final years. Problems with Mendeleev's table. Once he was finished, Mendeleev thought he had organized the elements systematically, but there were still some elements which didn't quite fit in as neatly as he wanted. This is because isotopes were not known in Mendeleev's time, and he made no provisions for them in his table. This meant that there was always going to be some level of inaccuracy in Mendeleev's work, even though he did also consider the elements' chemical properties as well as their atomic mass when sorting them. Mendeleev switched the order of tellurium and iodine in his table, because even though tellurium was heavier than iodine, the chemistry of iodine fitted better with the other halogen elements. It was a nagging problem that was not solved in his lifetime. The discovery of the proton led to the determination of atomic number for each element. This number is used to arrange the elements in the modern-day periodic table, which fits with Mendeleev's patterns. The modern periodic table. There are over 100 chemical elements which have been isolated and identified. Elements are arranged on the periodic table in order of increasing atomic number. Each element has one proton more than the element preceding it. This is done so that elements end up in columns with other elements which have similar properties. The table is arranged in vertical columns called groups and in rows called periods. Period. These are the horizontal rows that show the number of shells of electrons an atom has and are numbered from 1 to 7. e.g. elements in period 2 have 2 electron shells, elements in period 3 have 3 electron shells. Group. These are the vertical columns that show how many outer electrons each atom has and are numbered from 1 to 7, with a final group called group 0, instead of group 8. OEG. Group 4 elements have atoms with 4 electrons in the outermost shell, group 6 elements have atoms with 6 electrons in the outermost shell, and so on. Exam tip. The atomic number is unique to each element and could be considered as an element's fingerprint. The number of electrons changes during chemical reactions, but the atomic number does not change. Metals and non-metals in the periodic table. The metals that are further to the left on the periodic table do not have many electrons to remove from their outer shells. As you descend the groups, the outer shell electrons become further away from the nucleus due to increasing atomic size. This weakens their attraction to the nucleus. The further down the group an element is, the more easily it can react and lose its outer electrons. For the non-metals which are placed on the right-hand side, the opposite is the case. These elements have a lot of outer electrons, and it is more feasible for them to gain, or share electrons, to obtain a full outer shell. This is a key difference between metals and non-metals and influences their chemical behavior. It also clearly illustrates the important link between an element's atomic number and how it reacts, as well as its position on the periodic table. A summary of the general properties of metals and non-metals. Metals are good conductors of heat and electricity and have high melting point. Non-metals are poor conductor of heat and electricity. Metals have high density, whereas non-metals have low density. Metals are malleable and ductile, whereas non-metals are poor electrical conductors and are brittle. In general, non-metals tend to have lower melting points than metals. Most of non-metals exist in 2 of the 3 states of matter at room temperature, gases and solids, except bromine, which exists as a liquid. Thank you for your time. Please subscribe to this channel for more updates and learning skills.